This video has been made possible by Mitchell Dillman and Thunderbird Perch. Thank you for watching. Subscribe for more. We are watching. Hidden power can live in stones and shapes. This is a bold idea, yet one worth exploring. It suggests that ancient people might have understood and used natural forces without modern tools or complex theories. Today, the same fundamental principles could be at work, perhaps even harnessed by those with the knowledge to do so. This essay will explore a fascinating connection, a thread that ties the ancient geometry of the Great Pyramid at Giza to the raw geological power of a modern mountain like Pikes Peak. It is a story of how natural landforms and ancient shapes can potentially generate and move electrical charge. We will look at this idea calmly, with simple words. Let us first look at the Great Pyramid at Giza. It is a marvel of engineering, known for its size and precision. Yet, one of its most curious features is often overlooked. The four main faces of the pyramid are not perfectly flat. Each face is slightly indented from top to bottom, creating a subtle eight-sided shape instead of a four-sided one. This specific geometry is not random. It profoundly affects how air moves across its surface. The concavity can funnel wind, causing it to accelerate along the indented channels. This is a basic fluid dynamics principle called the Venturi Effect. When air is forced through a narrower space, its speed increases. That speed change has consequences. As the air accelerates, its pressure drops. The pressure drop can affect the air's electrical state, encouraging the formation of ions. Ions are atoms, so the pyramid's shape could create pockets of ionized air around it. This is not magical. It's a direct result of a shape interacting with a moving fluid, in this case, desert wind. The pyramid becomes an active participant in its environment, not just a passive monument on the sand. Imagine the vast surface area of the pyramid over thousands of square meters. This effect multiplies. The structure becomes a giant, static device conditioning the local atmosphere. Faster moving air on the indented faces could create a persistent sheath of charged particles around the stones. Simple to visualize. The pyramid is like a designed rock that combs the wind. Its edges and channels manipulate airflow deliberately. The result? A structure that might generate a small, constant electrical field just by standing in the wind. This is our first key. Geometry can influence energy. A man-made object, if shaped correctly, can alter the electrical properties of the surrounding air. Foundational idea we carry forward. It suggests the ancients may have understood physics we call modern. The pyramid is not just a tomb. Now, let us leave the sands of Egypt and travel to the Rocky Mountains of Colorado to Pikes Peak. This massive mountain is not smooth and uniform like the pyramid's dressed stone. It is a jagged, sprawling giant of granite, full of sharp ridges, steep cliffs, pointed rock formations. While the pyramid is a man-made example of a charge-generating shape, Pikes Peak is a natural one, operating on a colossal scale. Strong winds constantly blow across its summit and ridges. As this wind, full of dust, ice, moisture, rushes over the sharp edges of the rock, a simple physical process can occur: friction. This is triboelectric charging, the same principle that makes a balloon stick to a wall after you rub it on your hair. This process, happening across miles of sharp, rocky terrain, can be compared to a giant Van de Graaff generator. A Van de Graaff generator uses a moving belt sharp metal combs to strip electrons and build up a large static electric charge. And the countless sharp points of granite act as the combs. As the air molecules are forced over these points, electrons can be stripped away, creating a massive separation of charge. The air near the summit can become highly charged relative to the ground far below. This creates a significant difference in electrical potential, like the two terminals of a giant natural battery. This effect is not just a theory, it is observable. Mountain peaks are known for attracting lightning, and for strange electrical phenomena like St. Elmo's fire, a weather phenomenon in which plasma glows from a pointed object in a strong electric field. These are visible signs of the immense electrical forces at play. The mountain, by its very nature as a large, pointed object sticking up into the atmosphere, becomes a focal point for electrical energy. It is constantly interacting with the weather, the wind, the atmosphere's natural electric field, amplifying these effects due to its size and its sharp, fractal geometry. So, the mountain itself acts as the first part of a large-scale power system. It gathers and separates charge from the atmosphere. This is a crucial step. While the pyramid shows how a shape can create charge on a local level, the mountain shows how geology can do it on a regional one. The result is a vast reservoir of electrical potential, centered on the rocky summit. This charge does not simply stay in the air. It seeks a path to ground, a way to discharge and balance itself. The mountain's peak is the collector, but the energy needs a path to follow downward, into the rock itself. The charge gathered at the mountain's peak must go somewhere. It is drawn downward into the body of the mountain. Here, another natural process comes into play. The granite that makes up Pikes Peak is rich in a specific mineral, quartz. Quartz is a crystal and it has a remarkable property known as the Piezoelectric effect. The word itself simply means pressure electricity. When a quartz crystal is squeezed bent put under mechanical stress, it generates a small electric voltage. This is not a speculative idea. It is the principle behind quartz watches, gas grill igniters, many types of sensors. On a mountain, the scale of this effect is immense. The sheer weight of the rock creates constant pressure. Tectonic stresses from deep within the earth pull and push on the rock formations. Even the changing air pressure from passing storm systems adds and removes tons of weight from the mountain's surface. All of these forces act upon the countless tons of quartz crystals embedded within the granite. This constant squeezing and shifting can cause the crystals to generate a steady flow of electrical charge. This internal generation of power adds to the atmospheric charge collected at the peak, pushing a steady stream of what are called telluric currents down into the ground. Pure water is a poor conductor, but the water flowing through a mountain is far from pure. It is a rich mineral soup. As water seeps through cracks and fissures, it dissolves minerals from the rock, becoming conductive. This mineral-rich water fills aquifers and underground channels, acting like a network of natural wires. The electrical currents generated in the rock can flow into this water system, which can then carry the charge for great distances. The mountain's plumbing becomes the Earth's electrical wiring, moving energy from the place of generation to other locations. If such a natural electrical system exists with predictable currents flowing through underground pathways, it is logical to assume modern technology could tap into it. Imagine this schematic. This would not require massive new power plants. It could be done subtly using existing infrastructure. Public utilities have extensive networks, electrical grids, water systems running above and below ground. These systems could provide the perfect interface for accessing natural telluric currents. The key: tap the energy without it showing up on official balance sheets. Consider the existing electrical grid designed for alternating current at a fixed frequency, e.g. 60 Hz. The mountain's telluric currents would be more complex direct current, DC low-frequency waves. A sophisticated system could tap the DC power, convert it, inject it into the AC grid. If injection is phase-synchronized with the grid, it might not register on standard utility meters. Meters measure power drawn from central plants, not extra power added along the line. That injected energy becomes effectively free power, a surplus unseen in the national grid. Official accounting shows a facility using 100 megawatts secretly drawing 20 megawatts of converted telluric energy. Real power consumption: 120 megawatts. The extra 20 megawatts would be off the books, a ghost in the machine. This enables a kind of energy laundering. Natural power is cleaned by passing through the public grid, where it becomes indistinguishable from conventional power, accomplished at key interface points. Deep vertical utility shafts drilled through rock shafts that house equipment, shafts that house cables, providing access to geological strata that include water and shale, conducting the currents. A tap installed deep underground, far from public view. Feed energy into the grid via existing substations or transformers. Mask the operation as routine maintenance or part of a classified communications network, using the vast and complex utility infrastructure as cover. If a hidden energy source can be tapped so subtly, the next logical question is, why? What would be the motive for such a complex undertaking? The most straightforward answer is funding. Particle accelerators, high-energy lasers, advanced computing facilities are notoriously power-hungry. By augmenting their official energy budget with a free, untraceable source of power, these black projects could operate on a much larger scale than their public funding would suggest. The saved money could be redirected to other classified aspects of the research. This method creates a self-sustaining funding loop. The mountain generates the power, the utility grid hides the power, the project consumes the power, all without a clear financial trail. It is a way to turn a natural phenomenon into a covert source of capital. This provides a powerful incentive for any group that wishes to operate outside the bounds of normal oversight and public scrutiny. The energy itself becomes a secret currency, powering endeavors that may never be revealed to the public. Advanced Weapons Program Deep Space Initiative could be partially offset by simply plugging into the Earth. Beyond funding, there is a more strategic and sinister possibility: area denial. If one can tap and convert these natural energy flows, it is also likely that one can manipulate them. Amplifying the telluric currents, pulsing the telluric currents in a specific region, it might be possible to alter the local electromagnetic environment. Such alterations could have noticeable effects on living things. Some theories suggest that low-frequency electromagnetic fields can influence the human nervous system, unease, paranoia, headaches, disorientation. This is sometimes referred to as psychotronic warfare. Given this complete hypothesis, from generation by mountain and pyramid shapes to its potential use by secret projects, the final step is to consider how one might verify it. The idea is grand, but the methods for testing it can be simple and direct. It requires a targeted audit of physical locations and energy signatures. We must look for anomalies, data points that do not fit conventional models. The question is whether there is measurable evidence that aligns with predictions. The concept hinges on finding unusual electrical activity in very specific places. Two primary locations emerge: deep vertical utility shafts, natural mineral springs. The utility shafts cut directly through geological layers, forming the proposed circuit. They provide a direct conduit to the depths. Measure electrical potential and current flow in these shafts and compare to control locations. Are there unexplained DC currents present? Do these currents fluctuate with solar activity, storms, seismic events? These are simple questions answered with standard electrical measuring equipment. The deep mineral springs are the natural outlets of this underground system. They are where conductive water returns to the surface. The water should carry a signature of its journey. Test conductivity. Test mineral content. Test electrical charge. Test a spring near Pikes Peak and compare to surface water elsewhere. If spring water shows an unusual electrical charge or matching conductivity profile, it's strong evidence. So where start? Start where the water comes out. Springs are more accessible than secure utility shafts. They are the public face of the deep underground plumbing. They provide a direct sample of the medium carrying the charge. If tests at multiple springs show consistent anomalies, that justifies investigating deeper shafts. We must first follow the water, for it tells the story of the rock it has traveled through.